Good morning, everybody. Yes, this is part of a series on exploring the solar system, and this one in particular is about robots on Mars. So I'll be saying a little bit about Mars and Martians, talking about landers and rovers, and asking the questions, what have they found, and perhaps what are the next steps? It's only designed to be a relatively short talk. I think we'll have enough time for questions afterwards, either about Mars or about the solar system, or, well, what the hell, if you want to ask a question about the rest of the galaxy and the rest of the universe, that's what I'm here for. So man has always had a fascination with Mars for centuries, if not millennia. And when you say Martian, some people, especially people of a certain age, will think back to H.G. Wells and War of the Worlds. Either the book, or the radio broadcast, or the film, or perhaps, if you're a little younger, even the Jeff Wayne musical. And for those who don't even think about War of the Worlds, when you say Martian, perhaps when you say Martian, you actually think of Matt Damon, being the more recent film, of course. But we should just stop for a second and remind ourselves how absolutely amazing it is. Because when you think about it, humans, 100,000 years ago, some of us were still living in caves. And yet it's now possible for mankind to build machines, put them on the top of a rocket, send that rocket to another planet, have the machine land, have the machine roam around, and send back high-resolution imagery such as this. Mars appears to be quite arid, quite dry, a desert, but the rovers have found evidence that water has flowed on Mars. There have been rivers, there have been lakes, perhaps there have been oceans. One of the reasons the landers and the rovers are there on Mars is to try and answer these questions. If there's water in the past, is the water still there? Not on the surface, but is the water perhaps under the surface? And if there has been water on Mars, we think life on Earth started in the oceans. So if there's water on Mars, or has been water on Mars, is it possible that there's life there, even though we can't see any on the surface? So there are quite a few NASA or American rovers. There's also a Chinese rover. I haven't got time to talk about them all. I'm just going to pick some of the American ones because there's lots of useful information on the NASA web pages about landers and rovers that have come from the USA. The first was in 1976, the Viking lander. And since then, there have been a number of different landers and rovers. I'm going to be mentioning the two there, Spirit and Opportunity. In the years coming after that, there's a few more. Curiosity was in 2012 and Perseverance 2020. I'm going to explain the difference between these two rovers. I'm not going to talk about them all because of the time constraint we're on. I'm just going to mention something about those in red to give us some idea of how the exploration of Mars has progressed. So for me, the story starts in 1976. No, we didn't send Carl Sagan to Mars. This is just him in a desert with a mock-up of the Viking lander. It gives you an idea of scale. The Viking lander was about the size of a small car, roughly speaking. And I remember in 1976, I remember hearing the news that the Viking lander was on the surface of Mars, and then it sent back images of the red planet, the first color images from the surface of another planet. And I remember at the time, as well as being impressed by the fact that people were walking on the moon in the late 60s and early 70s, I was also amazed by the fact that on my TV, I could watch color images taken on the surface of another world. How do we get to Mars? Well, it only takes a relatively small rocket to send a lander or a rover to Mars. There's a relatively small rocket there. It's way smaller than, for instance, the mighty Saturn V rocket that got astronauts to the moon. The Saturn V, 3,000 tons to get the astronauts to the moon. But Mars is much further, but it only needs a much smaller rocket. Why is it that you need a huge rocket to go to the moon and only a small rocket to go to Mars? It's not about distance. It's about how much stuff you want to send there. It's about the mass that you're trying to lift off the surface of the Earth. So the Saturn V was designed so that it could lift more than 100 tons off the surface of the Earth and into Earth orbit. But with a Mars rocket, all you're doing is sending a lander or a rover that might have a mass of maybe 1 or 2 tons, not hundreds of tons, and therefore, again, you only need a smaller rocket to get it off the surface. Once it's reached escape velocity and left Earth, it doesn't really matter whether you're heading towards the moon or heading towards Mars. Yes, of course, it'll take longer to get to Mars, but you don't need a big rocket just because you're going further. Once you get to Mars, what happens? Here's what happened to Opportunity rover back in 2004. When it enters the Martian atmosphere, it starts to brake, an aero-braking maneuver. The atmosphere is thin, but it's still thick enough to start to slow down the vehicle as it's coming in. Once it's slowed down a bit, it deploys a supersonic parachute. At this point, it is still going faster than sound. And the supersonic parachute will slow it down to the point where it can start to eject the heat shield, and the rover itself is inside that little pyramid. And the question then is, how do you get this small rover onto the ground? You could use sophisticated rockets, but the cheapest way is to use airbags. So they just get it close to the surface, they slow it down as much as possible, get it to within 10 or 20 meters, and then literally just let it go and let it bounce. You don't have to worry about precision landing. You don't have to worry about the fact that the wind might be carrying you sideways. You don't need precision. You just need to get close, let it go, let it bounce. Of course, you need to make sure that your rover on the inside of this set of airbags is very secure. But after something like 20 to 30 bounces, it eventually comes to a stop. And then the airbags can be deflated, and then you can start to unwrap your rover. So it's a very clever design that automatically rights itself, and there's the rover right in the middle of this package. One of the first things it has to do is to get power. It has solar panels, so it needs to unhinge its solar panels. So out they come, and then these planes will again come across to give it the largest surface area that it can achieve within that particular footprint, as it were. Now it's starting to get some power. It wants to take the mast here with a camera on top and put that into a vertical position. So up goes the camera, and just behind it, something that looks like a table tennis bat. That is the aerial that allows it to communicate from the surface up to a vehicle in orbit and ultimately communicate with Earth. So it has a stereo camera on top of this mast, so it can look around, verify that, yes, indeed, I am the right way up. Everything seems to be good. It can tell Mission Control it's landed, and then Mission Control can give it the command to, okay, it's about time you started moving. Unfurl your wheels. The wheels are tucked underneath it, so it lifts itself up. Its wheels come out, and it now has six-wheeled locomotion. It needs to do a double check of what's in front of it because it doesn't want to trundle off directly into rocks. So it does a little scan with its stereo camera to make sure it knows where it's going. It looks at the rocks ahead and decides where it's going to go. Or more strictly, Mission Control tell it where to go based on what they see from its cameras. So it decides to turn away from these rocks, and then it's going to start on its mission. These first rovers from 2004, Spirit and Opportunity, landing in different parts of Mars, they had a design lifetime of 3 months. It was hoped that they would last longer, but they figured we've designed it in such a way and we think it's traveling across terrain in such a way that it ought to last at least 3 months, and hopefully a little bit more than that. What is it that ultimately dictates the length of time that a rover can go around on Mars? Well, remember, it's got solar panels to keep its batteries charged. And if we do a selfie, in other words, if we take that camera and instead of looking out to the horizon, if we tell the camera to look down, we see the solar panels. And here the solar panels are relatively clean, and we can see the red dust of the Martian surface in the background. And we also see a few little tire tracks around. But after a few months, what can happen? The Martian atmosphere is very thin, but it does have a lot of dust in it. The dust is very fine and is easily whipped up even by light winds. And so dust, Martian dust, can settle onto the solar panels. And after a few months, if that's what it looks like when it's clean, after a few months it can look like that. And you see the dust on the solar panels, you can almost not make out the rover itself. It looks like it's camouflage, because the dust on the panels is the same color as the dust on the surface. And if you start to put dust on solar panels, you limit the efficiency of how you can get energy, and so it's difficult to charge your batteries. You can't predict how much dust you're going to get. It depends on wind, it depends on weather. Sometimes some wind can come along and actually blow the dust off again. But the problem is you really need solar panels in order to make sure you can charge your batteries. If we think about Mars in terms of what's it like as a planet compared to Earth, the tilt of the axis of rotation, very similar to Earth. Earth is clearly bigger by a factor of 2 or so, but the tilt of the axis is similar, 23.5 degrees for Earth, about 25 degrees for Mars. And they take roughly the same length of time to spin. The Earth spins once in slightly less than 24 hours, and Mars spins once in a little bit more than 24 hours. So the day-night cycle of Mars and the seasonal cycle of summers and winters are very similar for these two planets. The big difference is the atmosphere. We have a nice thick atmosphere, so we can take the warmth of the sun during the day and we can use solar panels to charge things up, for instance. But at night, the temperature will fall, but it doesn't fall dramatically because we have an atmosphere surrounding us, which keeps the heat in. Effectively, the Earth has a duvet, which keeps us nice and warm at night. Mars doesn't have that. It has a thin atmosphere, so it can be heated by the sun during the day, but when you're on the night side, the temperatures can plummet. And rovers have to keep warm. If you take a rover, which is a bunch of mechanical and electronic wizardry, if you cool it down too far, it will freeze and it will die. So it is important that the rovers take the sunlight during the day from their solar panels, charge the batteries, and use the batteries to switch on heaters during the night. The daytime temperatures might be above freezing, especially during the summer months. The daytime temperatures can be above freezing and might even hit 20 Celsius. But at night, the temperature can easily drop to minus 100 Celsius or lower during a winter's night. And if the rover didn't have heaters, if it got that cold, it would be impossible to restart it. So that's why these solar panels are so important. And ultimately, that's what dictated the life of these rovers. They were landed in 2004. They had a lifetime expectation of quite a few months. Spirit actually lasted quite a few years. Opportunity, despite its 3-month lifetime prediction, actually roved on the surface of Mars for more than 14 years, way beyond the expectation. It shows you how well engineered these particular things were. But ultimately, dust got them in the end. Opportunity died in 2018, 14 or so years after it landed. And it died because it was a winter season. There was dust in the atmosphere, and the dust was so strong, it was a dust storm, and there was so much dust in the atmosphere, basically it blotted out the sun, which means it could not recharge its batteries during the day, which meant when night came, it didn't have enough power to keep itself warm. So as the sun was setting on that final day, we got the last message back from Opportunity. Battery low, getting dark. And that is the last we heard from Opportunity. It must have died that winter's night. NASA said, okay, we want to send more rovers to Mars. Spirit and Opportunity were great little rovers. We want to send larger ones that have more equipment on board and are more capable and can rove further, so we can explore more of the geology of Mars. How are we going to do that without this limitation of solar power? There is a way of getting power on spacecraft and rovers. They're called thermoelectric generators, and they don't rely on power from the sun. But there are a limited number of these devices, so they can't be put onto every space mission that's sent by the European Space Agency or NASA. But NASA decided that for the next couple of missions, Curiosity and Perseverance, they're going to come into the atmosphere and use parachutes just like Spirit and Opportunity, but they're going to land a little differently because they're much heavier than Spirit and Opportunity. So let's see how that worked. We're going to use Perseverance because Curiosity was very similar. So again, a small rocket gets it to Mars. Once you arrive at Mars, you aerobrake through the atmosphere. Heat shield keeps it nice and cool. There's Perseverance inside its shell, getting a bit rattled. But basically, it's slowing down. There are little jets there to help it steer towards the right place. Again, a supersonic parachute then slows it down. Once it's going slow enough, it's possible to eject the heat shield. And then what do? You drop it from a height. And you use retro rockets to put it into a steer towards the landing site. Cameras are looking down so it knows where it's going. And when it thinks it's over the right place, it doesn't want to touch down with those rockets because they'll kick up so much dust, the rover will get covered in dust. So the rockets have to stay fairly high. So how do they get the rover on the ground? It's too big for airbags. So what they do is they go into a hover and then they winch it down on cables. And then when it's touched down, they cut the cables with guillotines, off goes the sky crane and crashes well away from the rover. There's the thermoelectric generator on the back end of Perseverance. Notice no solar panels. It doesn't need any. This particular CGI of the landing reminds us with this long, slow pullback that we might have a few rovers on Mars, and in total we've had something like 6 rovers on Mars. But Mars is half the size of the Earth, and rovers can't rove that far. They don't go thousands of miles, they go kilometers or tens of kilometers during their life. And of course, with a big planet and only 6 rovers, we've got an awful lot of exploring to do. So we have to try and make sure that we put these rovers and landers down in the best place possible to give us a representative view of what is going on the surface of Mars. So there's a selfie of Perseverance, sometimes known as Percy, and its little helicopter Ingenuity. In this case, it looks like Percy is sort of like a nervous adult, just checking that the little toddler is still there and still safe. But how do you take a selfie? If you wanted to take a selfie, you hold up your phone, you smile, you click, and you're done. Not quite as simple with a rover, but it does have not only cameras on that mast there, it also has a camera on the end of its robot arm that it used to drill into rocks or do a little bit of digging. And it can use that robot arm to lift up and look down on itself. And it doesn't take a single image, it takes a whole load of selfies and then eventually stitches them together to get the picture we've just seen. There's the robot arm moving around, and the lens stays in the same position whilst the camera goes backwards and forwards to get all of those individual frames that can be put together to make the final selfie. And usually they take out the robot arm, or at least they stitch together the images that don't have the robot arm in it, so it looks like you're viewing the robot from a sort of floating position a couple of meters above it. So where did this helicopter come from? Why do we want a helicopter? Because it's not a bad idea. If we've got an atmosphere, the question is, can we fly on another planet? We couldn't do this on the moon with no atmosphere, but now we're exploring other planets with atmospheres. Maybe we can start thinking about flying machines. Rovers move fairly slowly. Helicopters have the advantage that they can scout a long way ahead and see what's over the immediate horizon. Where did the helicopter come? It came on the belly of Perseverance. It was under the belly there, A plate then dropped away to expose the helicopter, and then the helicopter was dropped onto the ground. Out come its feet. Once it's on the ground, Perseverance can roll away, and then the helicopter can do its flying. So Perseverance has now backed off quite a distance to make sure everything is safe. There's Ingenuity, the helicopter in the bottom left-hand corner there. And Perseverance then recorded the flights of the helicopter. It was designed to do at least half a dozen flights. It's actually done a few dozen. In this particular case, the audio might come across. There's a bit of wind noise there. But also, once it flies, you hear a little bit of a hum. That hum is the sound of the rotor blades of the helicopter. So you're listening to the sound of a spacecraft flying on another planet. These test flights were carried out, a few dozen of them, simply to see if it is possible to fly on another planet. It might be that future rovers have helicopters to help scout, but it's also thought that this will be really useful to visit other worlds that have thicker atmospheres. The Martian atmosphere is quite thin. The helicopter needed to have big blades. But there are plans to put a bigger helicopter into Titan, the moon of Saturn. Titan has a very thick atmosphere, which means you can have a helicopter that's capable of lifting much heavier equipment, so you can have a lot of scientific equipment. And the idea is there are plans to send a helicopter to Titan, the moon of Saturn. Moon of Saturn is quite interesting because we think, based on a simple lander, we haven't explored much, but we have sent a simple lander in to see what Titan looks like. The atmosphere is so thick we can't tell from outside what it looks like. We have to send a lander into the atmosphere, or ultimately what we want to do is to send a helicopter in. We think there are mountains, and there are lakes, and there are clouds, and it rains occasionally. It's a world that's much more, in a sense, interesting than the moon, which appears to be dead. It looks like Titan, the moon of Saturn, is a very interesting world to explore, which is why the idea of sending a helicopter there to go exploring this world is on the cards from NASA. When NASA have any mission, regardless whether it's a Mars rover or whether they're sending spacecraft out to explore Jupiter, Saturn, Uranus, Neptune, Pluto, whatever, they sometimes try and get people engaged by saying, do you want to come aboard? By which they mean, we'll give you a boarding pass if you like. So I asked for one, and NASA gave me a boarding pass for Perseverance a few years before it was launched to land in 2021. The boarding passes of anybody that wants one are all then put onto a chip, and this particular chip is located on this bracket. What is that bracket? That's the bracket at the back end of Perseverance. So in other words, you can have your name on Mars if you wish. My name is on Mars. When Perseverance explores Mars, I know that I am going with it in a metaphorical sense. And you can do this not only for Mars missions, you can do it if you want your name to go to Jupiter or Saturn or the outer solar system. NASA basically allows you to do this. It's free, it costs people nothing, it costs NASA essentially nothing, because all they do is add a few milligrams to the actual mass of a rover to get all of these thousands, no, not thousands, probably millions of names on the back there. So the idea is just to get people more engaged with the whole mission if you know that your name is sitting on the back of the rover. But why do we explore Mars? There's lots of reasons for wanting to explore Mars. You could say that we want to understand its climate and we want to understand its geology. Well, geology isn't quite the right word because geo means Earth. But if you think of studying geology, when you study geology, you study how the Earth works. But in many cases, we want to study other planets because it helps us understand the geology of Earth. Why is Mars different? It's smaller. It doesn't have a magnetic field. It has a much different atmosphere. Are the rocks on Mars in any way similar to the rocks on Earth? If we study geology of our planet as well as geology of other planets, we get a better understanding of both. Does life exist? That's one of the big questions that we've been asking for an awful long time. It doesn't necessarily need water for life to evolve, but we know of only one place where life has evolved, and that's here on planet Earth, and we think it started in the oceans. So if we know it's possible for life to start developing in the oceans, if you have liquid water, if you have the right minerals and elements, and if you have enough energy from an energy source, such as the sun, we know that life can start. So it's sensible to start looking where else might there be water to see where else life might exist. And we do now know, although we don't see rivers and lakes on the surface of Mars, we do see evidence that there has been standing water. Perhaps not oceans, maybe it was only lakes and rivers, but we know there has been liquid water. If liquid water has existed for millions of years, maybe life got a hold. And if water is still there, maybe life is still there. Probably not anything close to us, but still it could exist. And some people say we want to explore Mars with robots because ultimately that paves the way for human exploration of Mars. That's probably still a long way away. Remember, we're only just going back to the moon 50 years after the Apollo program, but it's on the horizon for human exploration of Mars. What we would really like to do is to get a closer look at Mars in the sense that the robots are drilling into rocks and trying to analyze what they're looking at, but there's a limit to the sophistication of the instruments we can place on a rover. What we would really like to do is to take some of the samples that Perseverance has been collecting. It's been taking rock samples, it's been taking atmosphere samples, it's been sealing them up in little ampules, and it's been leaving some behind and taking some with it. We would really like to get those samples back to Earth so that we can analyze them with more sophisticated instruments than are on board these rovers. So how do we get these samples that Perseverance has been collecting? How do we get them back to Earth? NASA and the European Space Agency had this idea. There's Perseverance, and it is joined by a lander that comes down. Perseverance then trundles over to the lander, takes all the samples that it has been collecting for the last few years and transfers them over from its own storage to the storage in this lander. You can see in this particular animation, it looks like there's a couple of dozen different rock and atmosphere samples. Having transferred them to the lander, what happens next? Well, the lander's a bit too heavy to lift off the surface, but it's got a little rocket inside it, and the samples have been placed into that. And that then flies off. There's Perseverance watching it go. It flies back to orbit, where it rendezvous with another spacecraft in orbit, and finally the samples are then returned to Earth. And then they are very carefully unsealed and examined by sophisticated instruments here on Earth. This is the so-called Mars Sample Return, a joint project between NASA and ESA, the European Space Agency. They decided to send Perseverance to collect the samples before they'd actually decided how they're going to get the samples back. They basically said, let's do step one, and then we'll figure out step two. Unfortunately, the funding to do this has stalled somewhat. So Perseverance is collecting lots of Mars samples, and at the moment, we are not quite sure how to get them back to Earth. It will happen, but we're not quite sure when it will happen. But in terms of what next, what's the future, I've been talking about a number of American rovers, and there is also a Chinese rover. The European Space Agency has decided to get on board with this whole idea of exploring Mars. Come 2028, this rover, called the Rosalind Franklin, will hopefully be sent to Mars. Perhaps you can see it's a relatively small rover using solar panels. It's going to have a limited lifetime for sure. But what makes this rover different from every other rover that's been on the surface of Mars so far is this black box that's on the front of the rover. This is a drill, and it should be possible to drill down through the surface and see if there's any water under the surface. It's been calculated that if water is there, it might well be less than 1 or 2 meters below the surface. So Rosalind Franklin, in a few years' time, will be able to drill into the surface of Mars, and if we verify there is liquid water down there, that could change everything. Because if there is liquid water there, and we think that's very probable, then it's always possible there's life down there as well. So this particular mission is well underway for launch in a couple of years. It's actually being put together, whoa, Airbus UK. It's not only European, it's being put together by us. There's a load of technicians that are putting it together essentially as we speak. I think somebody ought to tell them one of the wheels is missing. They seem to have replaced the back wheel with a shopping bag. I think they probably know that. They've still got a little bit of work to do there. But it is well under construction and it should be ready to fly very shortly. There's the people who built it. Give them a wave. Yeah, great. So that will be on its way. In a few years, you will see what results are coming out of this particular European rover on Mars. So if I've piqued your interest, you'll find more information on the National Space Agency of America and Europe and China. And I have some handouts if anybody's interested. And I will make electronic versions of these slides and a recording of this talk available to you in due course. Thank you very much. I'm happy to take questions.